Welcome to our poster. It is based on the topic analysis of coherence as a function of the ground to volume scattering ratio for forest region. The forest area selected for the study was Malhan Forest Range of Dehradun Forest Division, India. It was of subtropical forest type, and the keystone species observed in this study area was Shorea robusta, and also with the dense undergrowth vegetation. And the SAR datasets which was used for the study was a pair of RADARSAT-2 C-band datasets with a temporal baseline of 24 days. So the common scattering mechanisms that we observe in case of polarimetric decomposition modeling are double bound scattering, which is mainly observed from the interaction of the radar signals with the ground and the tree trunk, then followed by surface scattering, volume scattering, helix scattering, and wire scattering. This is mainly observed in case of coniferous trees with from the sharp edges of the needles. So in case of SAR datasets, the first acquisition was considered to be the master image, while the second acquisition was considered to be the slave image. So first we applied Yamaguchi 4-component decomposition modeling on the master image, from which we retrieved images for surface scattering, double bounce, volume, and helix scattering. Then we further calculated ground to volume scattering ratio based on the double bounce scattering and volume scattering for the forest region. Then with proceeding forward with the Boolean processing, we first co-registered the master and the slave image, and then we extract the complex coherence values for each for 3 polarization bases, which were linear, Pauli, and optical. And then we plotted the coherence values of each of these polarization bases against the ground to volume scattering ratio, and we generated these density scatter plots. So what we can observe from this density scatter plots is we can see that HV coherence has a lower range in the y-axis compared to that of HH and VV coherences. And we can see a similar extent in case of HV plus VH coherence. And this is mainly due to the high decorrelation, which is due to the presence of randomly oriented dipole scatterers. And in case of HH minus VV coherence plot, we can see it is centered at 0, and it is independent of the ground to volume scattering ratio values. And further below, we can see the optimal basis. Here, in each case, we can observe that it has an equiprobable distribution, and only the values, it is gradually decreasing when from optimal 1 to optimal 2, and it's the least in case of optimal 3. So the main conclusions which we can draw from this study are that the cross-pole coherences HV and HV plus VH represent the forest region best, and that can be further exploited for estimation of biophysical parameters. And the copole coherences HH, VV, HH plus VV, and HH minus VV has higher range of coherence values as compared to the cross-pole. This is mainly due to as they represent the stable scatterers. And we also observed that even when the target media, which was the forest region in this case, was kept constant for the study, even then we saw that there was changes. I mean, the coherence values were observed to change. Yeah. So thank you so much for your patient hearing, and I will be available through the chat if you have any further questions.